Good morning, good evening, good afternoon, everyone. I'm Mrs. Williams and welcome back to my channel. In today's video, we're going to start a new topic, which is two-way frequency tables. But before we talk about that, let's go ahead and write down the standard and the essential questions in our composition notebooks. Today's standard is MGSE9-12.S.ID.5. I can create a two-way table from two categorical variables. I can read values from a two-way frequency table. Today's essential questions are: number one, how do you create a two-way frequency table from a given set of data? Number two, how do you interpret the information given in a two-way frequency table to answer specific questions? Number three, how do you use given information to determine missing values in a two-way frequency table? And lastly, number four, how do you convert values in a two-way frequency table to relative frequencies? Make sure you write the standard and the essential questions in your composition notebook. So, what is a two-way frequency table? Pretty much, it is a different way to write a Venn diagram. And I'm going to put a picture of a Venn diagram right here. Now, you're probably already very familiar with Venn diagrams. It's a way that we can compare and contrast two different things. Well, a two-way frequency table can do the same thing. So let's look at an example of how we can convert a Venn diagram to a two-way frequency table. So here we have the types of smartphones in Miss Williams' math class, and we have this information displayed using a Venn diagram. So most of you probably already know how to read a Venn diagram. We have our two circles. One represents iPhone, one represents Android, and the intersection represents the students who have both an iPhone and an Android. The number on the outside, the 7, means the students who do not have an iPhone and do not have an Android. So we're going to try to display this information in this table. And this table is called a two-way frequency table. So each column and row intersect. So here and here, here and here. So this square here means the students who have an iPhone and has an Android. So if we look at the Venn diagram, which students or how many students have an iPhone and have an Android? Well, that would be the students who are in both circles. So right here. So that means right here we will put 3 because that's the number of students who has an iPhone and have an Android. Looking in this square here, this square would be the number of people who have an iPhone but does not have an Android. So that would be these people or these students because this number is only in the iPhone circle. It's not in the intersection and it's not in Android. So this 15 represents the number of people who have an iPhone but do not have an Android. So we will put 15. So let's look at this box. This box says does not have an iPhone, but does have an Android because this is where the column and the row intersect each other. So we're looking for those individuals who does not have an iPhone, but does have an Android. So we will look just in this circle here, and we will see that it's 8 because this 8 represents all the people in this circle who have an Android but do not have an iPhone. So we will put 8 here. And the last box is does not have an iPhone along with does not have an Android. So that will be the students who have neither cell phone. So that will be the number that's not in either circle. So the 7. So now we have displayed the same information in this Venn diagram as a two-way frequency table. Notice how it displays the exact same information, it's just displayed a different way. So I know some of you are probably asking then, why can't we just use a Venn diagram? Why are two-way frequency tables so important and why are they so much better? And why do we need to learn them? Well, let's look at another example that can better explain why two-way frequency tables are different from Venn diagrams. So let's look at this example. It says, let's compare the president's approval rating among different political parties. So here we're talking about two different categories. We're talking about the approval rating and we're talking about political parties. Now, under each one, there are different options or different choices that you have. For approval rating, you have the choice of approve, disapprove, or undecided. For political party, your choices are Democratic, Republican, or Independent. So you have a lot of things that you can compare and contrast. And with three things, if we wanted to express this as a Venn diagram, our Venn diagram would look something like this, where we have several different overlapping intersections, all meaning something different. Now we could express this information using the Venn diagram, but as you can see, it'll probably be very tedious and you may have some difficulty choosing which intersection that the appropriate choice would go in. So, while we can express this information using a Venn diagram, there may be a more efficient or simpler method, and usually that's going to be the two-way frequency table. This may be a little bit more simple to express our information. We can have each row represent one of the choices for approval rating, and then we can have each column represent the different political parties. So expressing it this way kind of clears up some of the confusion and still represents the intersections for each approval rating and political party. So for example, we know that there are 13 people who are Democratic and approve of the president, while there are 83 people who are Democratic and disapprove. And then there are 6 Democrats who are undecided. So we can use this table to answer questions regarding who approves and which political party they belong to. Expressing the information this way may be a little easier to read and has much less confusion. So from the example, you probably see that a two-way frequency table can display more categories than a Venn diagram. In a Venn diagram, we're usually only comparing two things, while a two-way frequency table can compare way more categories than a Venn diagram. So we can say that it's a little bit more efficient, or it can better organize variables or categories that has many different options. So now that we know the difference between Venn diagrams and two-way frequency tables, let's look at a little practice on how to read two-way frequency tables in order to answer questions and to gather information. So now we're going to look at some examples of how we can use a two-way frequency table to answer certain questions. And we can practice how to read the table. So question number 1 says, how many Republicans are still undecided about the president's administration? To find the answer, we would go to the column for Republicans and look for the row about undecided. So this is the column and this is the row. There are 39 Republicans who are still undecided about the president's administration. So we're just going to write that in. 39. Number 2 says, how many Democrats approve of the president's administration? So you will go to the column for Democrat and find the row for approve. There are 13 Democrats who approve of the president's administration. So we would put in 13. Number 3, how many independents disapprove of the president's administration? So we would go to the row for independent, or excuse me, the column for independent, and find the row for disapprove. There are 43 independents who disapprove of the president's administration. So we will go ahead and put that in. And change the color. Number 4, in all, how many people approve of the president's administration? So this question is a little tricky. It says in all. So that means all of the political parties. That means how many Democrats, Republicans, and Independents approve of the president. So to find that out, we would simply add 13 plus 83 plus 36, because this entire row are people who approve of the president. And if we add all those numbers together, we get 132. Change the color. Now it says, in all, how many people disapprove of the president's administration? So that means regardless of their political party, we want to know how many disapprove. So we will add 83 plus 13 plus 43, because this entire row are people who disapprove of the president's administration. And when you add 83 plus 13 plus 43, you get 139. Whoops. And lastly, in all, how many people were surveyed? So regardless of who they approve of and regardless of what political party they belong to, they just want to know how many people responded to the survey. So to do that, you would just add up all of these numbers, because that would be the total amount of people. So you would add 13 plus 83 plus 36 plus 83 plus 13 plus 43 plus 6 plus 39 plus 27. And when you add all of that together, you get 343. So that means that there's a total of 343 people represented in the two-way frequency table. Two-way frequency tables can also be expanded to show totals. We can add up each row and each column to find out additional information, such as the number of people in each column, the number of people in each row, and more importantly, we can add up all the numbers to figure out how many people we had in total. So let's look at an example of how we can find the totals of all the rows and all the columns. So you saw from the questions that sometimes it's best to know the totals for each row and each column. Well, to find the row total and the column total, you just add each up. So if I wanted to know the total for this row, I would just add up all the numbers in this row. And that would be 13 plus 83 plus 36, which gives you 132. So if I wanted to know the row or the row total for this, for the number of people who disapprove, I would just add up 83 plus 13 plus 43. which gives you 139. So what if I wanted to know the total number of people who were undecided? I would just add up all the numbers in the row for undecided. So 6 plus 39 plus 27, which gives you 72. So now let's figure out the column rows or the column totals. What if I wanted to know the total amount of Democrats? Well, I would just add up the column for Democrats. So I would add 13 plus 83 plus 6, which gives you 102. What if I wanted to know the total amount of just the Republicans? So I would add up all of the numbers in the column for Republicans. So that'll be 83 plus 13 plus 39, which gives you 135. Lastly, if I wanted to know the total amount of independent, I would add up every number in the column for independent. So I would add 36 plus 43 plus 27. So that would give you 106. Now this box here is a special box. This box gives you your grand total. It tells you the total amount of people in all, regardless of their political party or the approval rating. So if you add up 132 plus 139 plus 72, you get 343. The great thing is if you added up 102 plus 135 plus 106, you'd also get 343. So this is a way you can check your answer because you should get the same number if you add up this column with this row. Or if you just take all 9 of these numbers and add them up, you should also get this number, which is your grand total. It's the total amount of people in all. So let's look at one more thing about our table. The numbers that are shaded in the pink are called joint frequencies. I like to think of it because they join two different categories together, such as Democratic and approve, Republican and disapprove. It joins the two categories together. So these are the values that are kind of in the inside or the middle of the table. The numbers that are shaded in green are called marginal frequencies. And when I think of the word marginal, I think of the margin, which is that area that's right along the outside. Well, you can see that the totals are in that margin of the table or on the outside of the table. And these are going to always be your totals. So the marginal frequencies are your row totals and your column totals. So this is just two more vocabulary words that you can add to reference in the future. So why is this information important? Why do we need to know the totals of each row and each column? Well, all the numbers are related to each other, and all the numbers have to add up to the grand total. And we can use this information if we're only given bits and pieces of our two-way frequency table. For example, what if our two-way frequency table were missing values? Is there a way that we can figure out the missing values? That way we can still answer questions and make conclusions. Well, let's look at an example of how we can use the totals and the other information to figure out values that are missing. All right, so now let's complete the chart using the given information to determine missing values. So down here we have a two-way frequency table that's comparing sports and gender. And under sports, our choices are football, basketball, and baseball. For gender, of course, there's males and females. So we need to find a way to figure out the values that are missing. Well, it's kind of hard to figure out how many basketball are for males if I don't know the total. This row is missing quite a few values, and this row is actually only missing one. So there's a way that we can figure out what number goes here, because we know that 52 plus some number plus 60 has to be 150. So if we add 52 plus 60, what number could we then add to equal 150? Well, using a little bit of math, you could figure out that 38 has to go there, because that's the only number that we can add to 52 and 60 and get 150. Well, now that we know this number, we can actually figure out the one at the top. So what number can I add to 16 and get 38? Well, that number would be 22. If I add 22 plus 16, I get 38. Now we're able to figure out this row. Since this is for the total, all we have to do now is just add 40 plus 22 plus 15, because I know that this number is just equal to all three of these added together. And when we do that, we get 77. So now let's look at this row. We're still missing a lot of information. But if I look at the columns instead of looking at the rows, I see that I have way more information. I see that 40 plus some number has to be 52. Well, the only number that we can add to 40 and get 52 is 12. Let's look at this column. What number can I add to 15 and get 60? Well, there's several ways to figure that out. You can just guess and check, or you can determine that if I subtract 15 from 60, it'll give me that missing number, which is 45. Let's make that red. Now again, we have a missing total. Well, there's two ways to figure this one out. I know that this square is the total for this row. So I can add up 12 plus 16 plus 45 and put my answer here. But can you think of another way that we can get the total? Well, the same thing has to go for this column. I know that 77 plus some number has to be 150. So if we did 150 minus 77, it'll give me that missing number, which is 73. And if you added all three of these squares together, you should have also gotten 73. So that's a good way to check your answer to make sure that you're doing this correctly. In many cases, you will not be given the table with missing values. Sometimes you won't be given the table at all. You'll have to create one from a word problem. So I know a lot of you are already panicking and just regretting the fact that we have to do a word problem. But honestly, they're not that bad. Let's look at an example so that you can see a little strategy that can help you create a two-way frequency table. So this is our word problem example, and it says, Justine sent out a survey to the freshmen and sophomores, asking if they were planning on attending the homecoming dance. 92 freshmen responded to the survey, with 44 saying that they would be attending. Of the 101 sophomores that responded, 15 said they would not be attending. Organize the data given in a two-way frequency table. So the first thing that we have to do is figure out what are our two categories? What two things are we comparing? Well, we're comparing the student classification, in this case, freshmen and sophomores, and we're comparing going to the dance. And there's only two choices for going to the dance, attending or not attending. So we need a way to organize this information into this table. So you have to decide which one do you want to be the rows and which one do you want to be the columns. Well, I'm going to make the student classification our rows. And since I only have two choices, then that means I only have to take up two rows. So in my column, I would write freshmen, and in the next one, the next row, I will write sophomores. And the bottom will be our total. So if our rows are going to be for student classification, then that means our columns up here have to be going to the dance. And our two choices are attending, not attending, and of course, a column for our total. So now that we figured that part out, we just have to go back through the problem and enter in as much information that we can. So let's read it one more time. It says Justine sent out a survey to the freshmen and sophomores, asking if they were planning on attending the homecoming dance. So that sentence really didn't tell us much other than the information we already have. So let's keep going. 92 freshmen responded to the survey. So that did give us a little bit of information that we can use. So let's stop right there. It says 92 freshmen. That's let us know something. 92 freshmen responded to the survey. It doesn't tell me if those 92 freshmen are going or not going, but it does let me know how many freshmen responded. So that will be our total. So you will put in there 92 because I know that I have 92 freshmen. So let's keep reading. With 44 saying that they will be attending. Okay, that's another part that we need to look at because it gives us another number. With 44 saying they will be attending. Well, who are the 44 are we talking about? Let's read the whole sentence. 92 freshmen responded to the survey, with 44 saying that they will be attending. This sounds to me that they are still talking about the freshmen. So out of those 92 freshmen, 44 are attending. So I will put in 44 for freshmen that are attending the dance. Let's keep reading. Of the 101 sophomores that responded, there's another number. So let's highlight that. 101 sophomores that responded. Again, that 101 doesn't tell me who's attending and who's not. It just tells me there are 101 sophomores. So that probably means that there are 101 sophomores in total. So I'm going to go to the row for sophomores, and for total, I'm going to put 101. Now let's continue to read. 15 said they would not be attending. There's another number that we need to pay attention to. So let's look at that. But who are these 15 talking about? Let's read the entire sentence again. Of the 101 sophomores that responded, 15 said they would not be attending. So this 15 sounds like it's referring back to those 101 sophomores. So 15 sophomores are not attending. So I will go to the row sophomores, and not attending and put in 15. Well, that's all the information they gave us, but we still are missing a lot of data values. So this is where we will have to use some clues to try to fill in the rest of the table. Let's look at the first row. Here we do have a total. So I know that 44 plus some number has to be 92. So we can figure out how many are not attending by figuring out what number I can add to 44 and get 92. Or you can just do 92 minus 44 and get 48. So we know that there are 48 freshmen not attending. Let's look at the second row. There is some number that we can add to 15 to get 101. That means that the number of attending plus 15 has to be 101. And if we subtract 101 minus 15, we can get our answer, which would be 86. And if we check our answer, we know that 86 plus 15 gives us 101. In our last row, we don't have anything, but if we look at the columns, we have plenty of information. So instead of looking at the rows, let's look at the columns. This is the total for this column. So to figure out what goes here, I will simply just have to add 44 plus 86, which gives us 130. Let's look at the next column. This box is a total for this column. And to figure that out, all I will have to do is add 48 plus 15, which gives us 63. And lastly, we can figure out the grand total. Remember, the grand total always goes in this box. We can either add 92 plus 101 and get our answer, or we can add 130 plus 63 and get our answer. Or the last way is we can add up the squares in the middle and get our answer. Either way, we should end up with the same number, which in this case is 193. So there was 193 people that were asked in all. So now we've completed our entire table. Most of your word problems will be very similar to this, but the key to it is to just take each sentence line by line and putting in your information and then figuring out the boxes or the values that you are missing by using the given information. So now in that example, you see how all of the information is put together. We need to know how to read a table, how to find missing values, and how to create a table from just a word problem. The last thing we're going to talk about are relative frequencies. Well, each number in each box of the two-way frequency table is called a frequency. It's an amount. It tells the value or the amount of people or things in that category. But in many cases, we don't want to know the specific number. We want to know how much is that of the whole, or the percent of people in that category. So that's what we call relative frequency. And I'm going to put a little definition right here. And relative frequency means that we're just going to convert each number to either a fraction, a decimal, or a percent. Sometimes it's better to know a fraction, a decimal, or a percent rather than the specific number, because it lets us know out of how many people in the whole are we talking about. Sometimes it's better to say 20% of people rather than just saying 10 people. And I'll show you another example of that when we go to class. We won't explain that in this video. But just know that in order to turn any number into a relative frequency, all you have to do is put it over the grand total. Let's look at a couple examples of turning a frequency into a relative frequency by converting the number to a fraction, then to a decimal, and to a percent. So now I'm going to demonstrate how you turn a frequency into a relative frequency. So these are what we call frequencies, when they're just the plain numbers that we calculated from the word problem. So if we wanted to turn them into a relative frequency, meaning a fraction, decimal, or percent, we would have to do some calculations. So to turn any frequency into a relative frequency by creating a fraction, we simply just have to place the frequency, which are these numbers, in the numerator and the grand total, which is this number, in the denominator. So you can see in this table, I have 44 over 193, 48 over 193, 92 over 193. I have simply taken each one of these values here and placed them in the numerator, and my grand total, which is 193, has been put in the denominator. So now I have turned each frequency into a relative frequency by turning it into a fraction. So what if we didn't want a fraction for the relative frequency? What if we wanted to display our frequencies as decimals? Well, we could take that fraction and convert it into a decimal. And the way we do that is by dividing the numerator by the denominator. So we would take 44 divided by 193, and that gives us 0.23. We would then take 48 divided by 193, and that gives us 0.25. Next, 92 divided by 193, and that gives us 0.48. And we will do that to each of the fractions that we just created to get the decimals. Be sure that you are very, very careful when you round your decimals to make sure that you don't throw off your answers too much. Lastly, we can display relative frequencies as percents. So how do we turn decimals into percents? We simply just multiply the decimal by 100. So we will take 0.23 times 100 and we get 23%. 0.25 times 100 is 25%. 0.48 times 100 is 48%. And again, we will continue with the pattern until we have converted all the numbers in the table into percents. Well, that's all for this video, and I know some of you are probably a little bit overwhelmed, but just take each part of the video a little by little by little. The main things that I want you to take away from this video is that two-way frequency tables are very similar to Venn diagrams. We can compare and contrast and find similarities and differences between two categories. The other thing that I want you to realize is that all of the numbers in a two-way frequency table are usually related to each other, either by the totals, in which you can add and subtract numbers to figure out others. And the last point that I want you to try to emphasize or make note of is relative frequencies. The best way to turn a frequency to a relative frequency is to simply put that number over the grand total and then convert it to a decimal or percent. Okay, so it's time for a little bit of motivation and inspiration, especially since this video is probably going to be a little bit lengthy, but I know you all can do it. I know that you will persevere and make me proud. But for a little motivation, I'm going to read this quote off my phone because it's a little lengthy. And it's, mathematics is not about numbers, equations, computations, or algorithms. It's about understanding. So, especially since you have to watch this video, just make sure that if you're getting anything from my video, that you get an understanding. Before I go, I want you to go ahead, if you have any comments, questions, concerns, or strategies that can help me improve my videos, then leave that below in the comments. If my quote resonated with you, or you have any thoughts that you want to share with me, then you can leave those comments as well, or just tell me in class. If you learned anything from my video and you find them helpful, then just give me a thumbs up, and I'll talk to you later in the next video. Bye!